The third and final part of this same problem. Well, here we are, what we've done before. We've got the production possibilities curve from part one. We figured out where we'd be if all of them did nothing but lawns, if they all did nothing but cars, if they all did half and half, if Yakov did each activity half and half, and Charles did only cars, and Gilberto only did lawn. Okay, got that here. Points A, B, C, and D. And we've got here the opportunity cost that we calculated. Okay, let's scroll down here. We figured out that Yakov had the lowest opportunity cost for producing a car. Charles was the next lowest. I'm fudging that again. I don't know why I can't say that name. Gilberto had the highest opportunity cost for producing a car. Therefore, if we're going to produce nothing but, if we start out producing nothing but lawns, and we move one worker over at a time to produce cars, we're going to start with Yakov. He has the lowest opportunity cost. We'll lose the least amount of lawns if we move him over. Gilberto, we'll move him last because he's the best lawn guy. We're gonna lose a lot of lawn productivity if. So we'll only move him over if we're desperate. Okay, so we're going to now do a production possibilities curve for the whole economy here. Here's lawns on this axis, cars on this axis, just like before. But now this is everybody, okay? This is everybody. Then our whole economy means all three of these guys. So if we're doing nothing but lawns, as we saw here, as we saw here, if we do nothing but lawns, those are our points. We can do 40 lawns, no cars. Okay, so there's our first point right there. And now the question calls for us to move over one worker. Well, we're going to move over Yakov, right? So if we move over Yakov from lawn production to car production, what do we lose? Okay, here's Yakov right here, where we're going to gain 20 cars, but we're going to lose 10 lawns. Okay, so we're currently producing, the economy is producing 40 cars. We move Yakov away from lawns to car. I'm sorry. If we currently have the economy producing 40 lawns, but now we're going to have Yakov start producing cars. That means we're going to give up 10 lawns. We're going to gain 20 cars. So that means we are going to be, well, there's 30 right there. We're going to, we don't want that. And 20, there's 20 cars. Well, we don't want that either. Jeez. What we want, there's our point. There's our next point on our production possibilities curve. Now we're going to move over one more guy. Okay. That would be Charles, because Charles has the next highest opportunity cost. We've already moved over our least costly worker. Now we're going to move over our next one. So Charles. So what's the situation with Charles? Whoops. Oh boy. Okay, there we go. Charles. Well, we're going to lose 10 more lines, but we're going to gain 10 cars. Okay? So, moving over Charles. Is going to put us at 20 lawns, but we're going to gain 10 more cars, so that puts us at 30 cars. So that point would be about right there. And last of all, we're going to move Gilberto over. And what does that mean? Here we're going to lose 20 lawns and gain 10 cars. Okay, I don't know if the artwork is the best there. Seems like there's a kink. I'm not sure if that's exactly where the kink is. I think there's another kink in there, but that's my artistry is not the best. But that's where we get the points. And in Aplia, you'll we've got the just the standard math here. Cars are the x coordinate, lines are the y coordinate, and they're like this, x, y. So you would plot these points, this point here, and that point. That would be 2030. That would be listed as 2030. Okay, so 2030. You find that on your graph and you smack it. Boom, there we are. That's where you plot that point. All right, now it wants us to plot the other points, the points I've been talking about that we had to save. Okay, here we go. Point A, point B, point C, point D. We're going to plot those points. Okay, point A is 40 lawns and 0 cars. And that's just right there. Okay, that's point A. Point B, that's 0 lawns. Well, let me highlight it. That's 0 lawns and 40 cars. And that's point B right there. So we've got point A, point B. Now how about the other points? Point C is going to be this one here. 20 lawns and 20 cars. It's right there. Here's 20 cars. Here's 20 lawns. There we go. That's point C. And last of all, our suffering is about to come to an end here. Point, where'd it go? Oh, there we are. We're shot at point D. Right here, 25 lawns and 20 cars. 25 lawns right there, and 20 cars. That's point D right there. Okay, it goes on to talk about efficiency. Okay, any point on the graph, any point on the production possibilities curve is efficient. Any point beyond the production possibilities curve is unattainable, at least at the present time. Economic growth, we model that with a shifting out production possibilities over time. But as you can see right now, point C and point D are inside the production possibilities curve. That means it's inefficient. So the lesson there is specialization and exchange, right? Point D and C, as you recall, you can see here, is when Yakov wasn't specializing. He was doing half of each activity. Now Charles was specializing in cars, Gilberto was specializing in lawns, but Yakov was not. That was enough to place point D inside the production possibilities curve, inefficient. We're better off, we'd been better off if Yakov had specialized. And over here, point C was even worse. Point C was when everybody was doing half and half, and that placed them even further inside the production possibilities than point D. Point D was when only one of them was not specializing. Point C was when all three of them was not specializing. So, all right, that does it for this little exercise.